I want to start this video with a confession. For a long time in my career, I genuinely believed that most machine learning problems could be solved if I just tried harder on the model. And I don't mean this metaphorically. I mean different architectures, more features, longer training, and more hyperparameter tuning. At that time, it felt like the responsible thing to do as an ML engineer. This mindset of model first followed me everywhere. When I was teaching, students would ask, which algorithm should I use? And I would answer with algorithms. When I became an engineer, I did the same thing. When models failed, my first instinct was never about, is this the right problem? But it was always about, what model should I try next? There was a project early in my career that finally broke this illusion. On paper, everything looked reasonable. We had data, we had labels, we had a clear deadline. But nothing worked. Our accuracy plateaued. Our stakeholders were unhappy, and every iteration felt heavier than the last one. And the worst part, I kept telling myself, just one more model, just one more training. Weeks passed and then months. The realization didn't came from a paper or a metric. It actually came from a very uncomfortable conversation I had with my boss back then. My boss asked a simple question: what decision is this model actually helping us make? And I didn't have a clean answer. That is when it hit me. The model was not failing. The problem definition was. So here is the lesson I learned the hard way. Most machine learning problems are not model problems. When I say most ML problems are not model problems, people usually nod, but it actually feels more abstract. So let me make this very concrete and very clear. I have seen the same four issues repeat again and again across different companies, different teams, and even different research projects. The first one is vague objectives. This usually sounds like, we want to improve user experience, or we want a smarter system. Okay, improve how? Do you want to improve number of clicks? Do you want to improve the time spent? Do you want to improve fewer errors? Do you want to improve faster decisions? I have worked on projects where the objective changed halfway through without anyone realizing it. No model can coverage if the target itself is moving. The second issue is mismatched labels. And this one is actually more common than any other issues. You think you are predicting quality, but your labels actually represent convenience or availability or whatever was easiest to log. I have seen teams train models on proxy labels for months only to realize later that the label never represented the real world outcome. At that point, model performance doesn't matter because you are optimizing the wrong signal. The third problem is unrealistic expectation. This often sounds like, can we get 95% accuracy? Without asking, is that even possible with this data? Remember, some problems are inherently noisy. Some decisions are ambiguous. And no amount of deep learning will remove uncertainty from human behavior. So remember, machine learning does not eliminate uncertainty. It barely manages it. Finally, the fourth one, poor feedback loops. This is the silent killer, actually, from my opinions. You deploy a model, but you don't know when it's wrong. Or worse, you find out months later. Without fast feedback, teams keeps improving models that are already misaligned. At that point, machine learning becomes like a theater. It looks impressive, but it doesn't learn. So if you notice, none of these problems fixed by a better model. They are actually fixed by clear thinking, maybe better questions, and tighter loops between data and decisions. The third one is the most important, tighter loops between data and decisions. That's what senior machine learning work looks like. Once this clicked, my entire approach changed. I started asking different questions, not how do I improve accuracy, but more like what decisions will this influence? What happens if it is wrong? What is the simplest thing that could work? Ironically, I started using simpler models and they worked. And most importantly, they shipped. Many of my work has been used right now in industry. They are depend upon very simple machine learning models. So if you are early in your career, here is what I want you to take home. Spend less time chasing newer, smarter, clever models. Spend more time understanding where your data comes from, understanding why labels exist, understanding who actually uses the output. That is where senior level judgment comes from. I have many more such lessons from my engineering, teaching, and managing ML teams background, and I'm hoping to share my honest reflections here. So I hope I see you in the next one. Have a nice one. Thank you.